projects. In this video, we are going to explain about the project title, A Multitask Learning Approach to Hate Speech Detection Leveraging Sentiment Analysis. Introduction. The project acknowledges the increasing prevalence of aggressive and hateful language in social media, necessitating the detection of such content. Given the immense volume of data posted daily, the project focuses on automating the detection process through advanced machine learning techniques. Hate speech is defined as harmful speech that promotes discrimination, hatred, or harm towards individuals or groups based on specific characteristics. The project underscores the importance of identifying and combating hate speech due to its potential to incite prejudice, hostility, and emotional distress. Recognizing the challenge of manually tracking vast amounts of content for hate speech, the project employs natural language processing (NLP). NLP, a field of artificial intelligence, allows for the automated analysis and understanding of human language, providing a crucial tool to identify and combat hate speech effectively. By leveraging NLP, the project aims to contribute to the efforts in countering hate speech online through automated detection methods. Objective. The core objective of this project is to create an advanced system proficient in identifying hate speech within textual content. To achieve this, a novel approach involving multitask learning (MTL) is employed. MTL allows the model to learn two essential tasks simultaneously: detecting hate speech and analyzing the sentiment expressed within the text. By jointly learning these tasks, the model gains a comprehensive understanding of the text, improving hate speech detection accuracy and effectiveness. The project adopts a diverse range of algorithms, including advanced ones like BERT, PETO, BiLSTM, BiRNN, BiGRU, GRU, RNN, LSTM, CNN, as well as traditional machine learning algorithms such as SVM, Random Forest, XGBoost, and Multilayer Perceptron. Additionally, an ensemble approach employing a voting classifier is implemented to harness the unique strengths of each algorithm. This diverse algorithmic approach ensures optimal performance and accuracy in hate speech detection. The ultimate goal of this project is to provide users with critical insights regarding the presence of hate speech within the input text. By offering this valuable information, the project aims to contribute to fostering a safer online environment. Users can make informed decisions about the content they interact with, thereby creating a digital space that is more inclusive, respectful, and free from hate speech. This initiative aligns with the broader objective of promoting a positive and secure online community for all users. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, essential libraries and packages are imported to provide the necessary tools and functions for the project. Libraries like NumPy, Pandas, Scikit-learn, TensorFlow, and Keras are likely imported to enable data manipulation, machine learning, and deep learning tasks. Exploring the dataset. Hate speech and emotion dataset. This module involves loading and understanding the hate speech and emotion dataset. Exploratory data analysis (EDA) techniques are employed to grasp the dataset structure, features, and potential challenges. Understanding the dataset is crucial for subsequent processing and modeling steps. Data processing. This step involves cleaning and preparing the data for further analysis. It includes tasks such as handling missing values, text normalization, removing duplicates, and addressing imbalanced data issues. Data processing ensures the data is in a suitable form for training and testing models. Visualization using Seaborn and Matplotlib. Visualization is a crucial step to gain insights and understand the dataset's characteristics. Seaborn and Matplotlib, popular Python visualization libraries, are used to create various plots like histograms, bar charts, heat maps, etc., providing a visual representation of the data distribution, correlations, and patterns. Data cleaning. This module focuses on cleaning the dataset, addressing any inconsistencies or inaccuracies that could impact model performance. It involves tasks like handling missing or incorrect data, removing irrelevant features, and ensuring the data is well structured and ready for further processing. Tokenization based on BERT for TL and Keras for deep learning, and GenSim with fast text for embedding. Tokenization is a crucial step in natural language processing NLP projects. In this project, different tokenization approaches are used. Tokenization based on BERT is employed for transfer learning TL, Keras for deep learning models, and GenSim with fast text for creating word embeddings. Tokenization converts text into smaller units tokens, enabling efficient processing and analysis of textual data. Splitting the data to train and test. This step involves dividing the dataset into two parts, training and testing sets. The training set is used to train the machine learning or deep learning models, while the testing set is kept separate and used to evaluate the model's performance. Proper data splitting is essential to ensure accurate model evaluation and avoid overfitting. Building the model, hate speech and emotion classification. BERT. BERT, bidirectional encoder representations from transformers. BERT is a transformer-based model that understands context and relationships among words in a sentence. It excels in capturing intricate patterns and semantics in text, making it a powerful tool for hate speech and emotion classification. BETO with transformer. BETO is a BERT model specifically trained for the Spanish language. It functions similarly to BERT but is fine-tuned to handle Spanish text, making it suitable for projects involving text in Spanish. MTL, multitask learning with transformer. MTL involves training a single model to perform multiple tasks simultaneously. In this case, a transformer-based architecture is utilized to jointly learn hate speech detection and sentiment analysis, enhancing model understanding and accuracy. BiLSTM, bidirectional long short-term memory. BiLSTM is a recurrent neural network variant that can understand context in both forward and backward directions. It is efficient in capturing long-term dependencies in sequential data, making it suitable for hate speech detection. BiRNN, bidirectional recurrent neural network. Similar to BiLSTM, BiRNN captures context in both directions but using a simpler recurrent neural network structure. It's valuable for sequential data analysis. BiGRU, bidirectional gated recurrent unit. BiGRU is another variant of recurrent neural networks effective in capturing bidirectional context in sequential data. It's computationally more efficient compared to BiLSTM. GRU, gated recurrent unit. GRU is a type of recurrent neural network known for its efficiency in capturing sequential patterns. It's useful for hate speech and emotion classification tasks. RNN, recurrent neural network. RNN is a fundamental recurrent neural network architecture used to capture sequential information, albeit less efficient in handling long-term dependencies compared to its bidirectional counterparts. LSTM, long short-term memory. LSTM is a type of recurrent neural network specifically designed to address the vanishing gradient problem, making it effective in capturing long-term dependencies in sequential data. CNN, convolutional neural network. CNN is well suited for tasks involving grid-like data such as images, but can be adapted for text analysis through techniques like 1D convolutions. It's effective in capturing local patterns in text data. Ensemble model of voting classifier. The ensemble model combines the predictions from multiple base models, example BERT, BiLSTM, SVM, and assigns the final prediction based on a majority vote. This often improves overall prediction accuracy. SVM, support vector machine. SVM is a traditional machine learning algorithm effective for binary classification tasks like hate speech detection. It finds a hyperplane to separate the classes in the feature space. Random forest. RF is an ensemble learning method that combines predictions from multiple decision trees to improve accuracy and robustness. XGBoost. XGBoost is a powerful gradient boosting algorithm known for its efficiency and effectiveness in various machine learning tasks, including classification. MLP, Multi-Layer Perceptron. Multi-layer perceptron is a type of feed-forward neural network where information flows in one direction, from input to output. It's a versatile architecture capable of handling various tasks, including classification. Training the model. The training process involves building and fine-tuning the selected modules. MLP, Multi-Layer Perceptron, Gradient Boosting GB, Random Forest, and a voting classifier. These models were chosen due to their high accuracy in hate speech and emotion classification tasks. Building the model with MLP or GB or RF or voting classifier since their accuracy is high. Each of the selected models, MLP, Gradient Boosting, Random Forest, is built and trained independently using appropriate training datasets. Additionally, a voting classifier is constructed to combine the predictions from these models to improve the overall prediction accuracy. Flask framework with SQLite for sign-up and sign-in. Flask, a micro-web framework for Python, is used to create a web application. SQLite, a lightweight relational database management system, is integrated to manage user authentication. Users can sign up and sign in to interact with the system. User gives input. Users provide their input, which is then pre-processed. This pre-processing step involves tasks such as tokenization, stopword removal, and text normalization to ensure the input is in a suitable format for prediction. The given input is translated and pre-processed for prediction. If the input is in a language other than the model's trained language, translation to the model's language is performed. The input is then pre-processed to align with the requirements of the trained models, ensuring accurate predictions. Trained model is used for prediction. The pre-processed input is fed into the trained MLP, gradient boosting, random forest, and voting classifier models. Each model predicts whether the input contains hate speech or emotions based on its training. The predictions from the voting classifier offer an aggregated prediction based on the consensus of the individual models. Final outcome is displayed through frontend. The predictions generated by the models are displayed to the user through the front end of the application. The outcome typically includes information about whether the input contains hate speech or is related to specific emotions. Users can then interpret these results and take appropriate actions based on the provided analysis. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is hatespeech.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py. This command will execute the Python script and perform a runtime check for any syntax error or logical issues. Now hit enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this, and port, which is this. Now copy this local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The home page of the project is displayed in the browser. This is the front end built using Flask framework. Now click on sign up button. If you are a new user, we need to register first. But I have already registered, so click on sign in button. We need to enter the username and the password which we have created. I have entered the username and the password. Now click on login. This is the home page of the project. Here we need to enter the message, and after entering the message, we will classify the tweet and then we will predict the sentiment of the tweet. So I'm entering the message. So this is the message which I have entered. Now click on predict. So here we can see we got the results for the tweet. The given input is this. The tweet is classified as neither, and the sentiment of the tweet is sadness. Now let us enter some more messages and check the sentiment. I'm entering one more message. So this is the message which I have entered. Now click on predict. So here we can see the given input is this. The tweet is classified as offensive speech, and the sentiment of tweet is happy. Now let us enter some more messages. So I'm entering one more message. This is the message which I have entered. Now click on predict. So here we can see this is the given input. The tweet is classified as neither, and the sentiment of tweet is fear. Now let us enter one more message. I'm entering the message. This is the message which I have entered. Now click on predict. This is the given input. The tweet is classified as neither, and the sentiment of the tweet is anger. So in this way, by entering the message, we can classify the tweet and we can predict the sentiment of the tweet. The conclusion of the project is integrating sentiment analysis with hate speech detection improved accuracy by considering the emotional context within the text. Understanding the emotional tone aids in more accurately identifying hate speech, as it provides additional contextual cues that traditional analysis might overlook. This integration enhances the hate speech detection model's ability to interpret text in a nuanced and informed manner. The project conducted a comparative analysis and discovered that MLP, multi-layer perceptron, random forest, XGBoost, and a voting classifier demonstrated superior accuracies in hate speech detection. This observation underscores the effectiveness of ensemble models, where multiple models' predictions are combined, and traditional machine learning approaches. The ensemble approach and traditional algorithms collectively contribute to achieving higher accuracy in detecting hate speech. The project successfully integrated trained hate speech detection models into a user-friendly Flask-based interface. This interface allows users to input text, which then undergoes pre-processing and translation as needed for hate speech prediction. By implementing a user-centric interface, the project ensures accessibility and ease of use, enhancing the user experience and making hate speech detection more accessible and practical for individuals interacting with the system.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.